Hey guys, welcome back. In today's video, we're going to be talking about computer networks and how computers send information between each other locally and to other computers outside of their network. Before we get started, I just want to thank you guys for taking time out of your day to view my content, and don't forget to leave me a like, a follow, or a subscribe depending on where you're seeing this. All right, so let's jump right in. So the first type of network we're going to be talking about is called the LAN, or a local area network. So these type of networks are typically smaller, right? It could be anywhere from like two computers to 1,024 computers. Like you could have a bunch of computers, but what LAN basically means is they're all on the same network. They're all local, right? It, they don't have to reach out on the internet to talk to each other and send data. They can do it through their local hub. Now, typically the best way to send information between computers is through cables. Now, everyone kind of recognizes these. These are Ethernet cables, and basically what Ethernet is, it's a data standard in which we kind of send information between computer to computer. Ethernet sends data in 1500 byte packages called frames. So if you were sending a big file, that big file would be broken down into thousands of frames. Each data frame not only contains the information that you're trying to send, but it also has vital information about the computer that's sending it and the computer that's receiving it. Now, every computer has a network card, which allows the Ethernet cable to be plugged in. We identify every computer on a local area network or a LAN by a unique identifier called a Media Access Control Address, also known as a MAC address. Now, this MAC address is actually burnt into your network card by the manufacturer to uniquely identify that computer. MAC addresses are also known as physical addresses, and these addresses are included in the Ethernet frame when sending and receiving information, both from the sender's MAC address and the receiver's MAC address. So when there are multiple computers trying to talk to each other on a local area network, this is kind of like a simplified version of what a frame going through the Ethernet would look like. You would have your sender's MAC address, your receiver's MAC address, the data you're sending, and then you have something called a frame check sequence that basically makes sure that your data is uncorrupted when it arrives. The MAC addresses themselves are just a 48-bit hexadecimal code. Hexadecimal is just a different way of kind of ordering things so that computers can read them better. For example, if you look on the left, this is kind of like the decimal row. We could see that that's how we normally count: 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Hexadecimal only goes up to 9 because computers only read zeros and ones. So if you start using ones and zeros like you do in 10, then it'd be very confusing to read data for computers. So you have to switch over to numbers to finish the alphabet. All right. On a local area network, computers are hooked up to something called a hub or a switch, and I'm going to explain the difference for both of them. To help you guys understand the difference, I drew you guys some diagrams. So this is a hub. This is a 4-port hub, which has 4 computers connected to each other. Now, let's say computer A wanted to send a 10 megabyte file over to computer D. The data is sent from the computer to the hub, where a repeater, something called a repeater in the hub, basically makes a copy of the data and sends it to all of the computers connected to the hub. Because each computer frame has a MAC address associated with it, the hub basically tries to match up the requested MAC address with the sender's MAC address, and if it matches, the data goes through, and if it doesn't, the data just gets erased. So basically, like in a nutshell, that's how hubs work. they are kind of inefficient because, they're sending the same data to every single computer on the network, which probably takes a lot of time. So people invented something called a switch to remedy that problem. All right, so here we have a switch, and we have the same example. Computer A is trying to send computer D a 10 megabyte file, and as you guys know that there's MAC addresses associated with every single computer on the network. And what the switch does that the hub doesn't is it actually memorizes every single MAC address that is plugged into the switch. So instead of kind of sending the same file to every computer and like hoping for the best, it actually knows exactly where to route the data. So that's how basically computers talk on a local area network. They send frames to a hub or a switch that basically sends information between each computer. Now, what happens if a computer on a local area network needs to send information to somebody on another local area network? A wide area network is a technology that connects your office, data center, cloud applications, cloud storage together. It is called a wide area network because it spans beyond a single building or large campus to include multiple locations spread across a specific geographic area or even the world. And this is an example of a wide area network. You can see that there are multiple local area networks connected together. So in order for us to communicate from one local area network to another, we can't use the switch or the hub. We have to use something called a router. A router is a networking device that forwards data packets between computer networks. Routers perform the traffic directing functions on the internet. Data sent through the internet, such as web pages or email, is sent in the form of data packets. So to understand the function of a router, you have to understand kind of how it was made. So basically, in the 1970s slash like 1980s, Advanced Research Projects Agency Network, ARPANET, was trying to develop a way to kind of connect different local area networks via cables in the United States. So the first wide area networks were really like universities and like military bases. There were only like maybe like 5 or 6 of them spread across the country, and the whole project was trying to connect them. Now, in order to identify the different local area networks, IP addresses were created. IP addresses do two things. The first thing is to identify which local area network you're a part of, and the second is to give you a unique host ID. ARPANET was kind of like the spearhead organization that kind of wanted to connect the local area networks in the United States, kind of in the USA's own intranet instead of the internet. But nowadays we have multiple networks, multiple local area networks that connects into a wider area network called the internet. And these IP addresses that are assigned to each network are assigned by a different agency now. The Internet Assigned Number Authority is a standard organization that oversees global IP address allocation, autonomous system number allocation, root zone management, and the domain name system, media types, and other Internet protocol related symbols, Internet, and numbers. So these data frames are also holding the information for these IP addresses. So just to quickly summarize, let's go over the difference between a MAC address and an IP address. So MAC addresses are used on local area networks to help the hub or switch identify individual devices. IP addresses are really used for wide area networks to help identify basically one area network from another and to send information between each other. All right, guys, so I think that is it for today. I don't want to make this video too long. If you guys learned something and enjoyed the content, please leave me a like, a follow, or subscribe, depending on what platform you're seeing this on. I really do appreciate it, and I will continue to bring you guys cryptocurrency information and computer information to help you guys get more informed. And I hope you guys have a great day, and I'll see you guys in the next one.